Hey, ladies and gentlemen, welcome back. So we're going to start talking about mole conversions using molecules. So you don't have these notes, so you're going to write these down on a separate sheet of paper. All right, so the question's going to say, let's say how many molecules and we'll make it easy. We'll say molecules of water are in 15 moles of water. Okay, so just like every dimensional analysis problem we've done since September, we're going to start what we know. And we know we have 15 moles of H2O. Now, we want to go to molecules, so molecules will be in your numerator. And then 1 mole will be in your denominator. Now, the number that goes along with molecules will be Avogadro's number. So 6.022 times 10 to the 23rd. So if we solve this, 15 times 6.022 times 10 to the 23rd, I would get 9.03 times 10 to the 24th molecules of water. Now remember, when you're putting times 10 in your calculator, you're not going to use times 10. You're going to use the E button, so second and then comma. We'll bring that E up on the screen. Okay, so there's one example. Now, say it says how many atoms of propane, and propane is C3H8. We'll say are in 5 moles of C3H8. So, start what we know, 5 moles of C3H8. Now, we can't just go to atoms. We remember from back in October that atoms, molecules, formula units, representative particles, all equal Avogadro's number for single atoms. But we look here, C3H8 is definitely more than 1. All right, so we have to go from moles to molecules. And you ask, why do we go to molecules? Because C3H8 is a molecular compound. And once again, if you ask, how do I know it's a molecular compound? We have 2 nonmetals. We have carbon and we have hydrogen. So we're going to go to molecules. So we'll have Avogadro's number on top. All over 1 mole. Now, we look. We want to go to atoms. So in this 1 molecule of C3H8, I want to know how many atoms I have total. So I have 3 carbon atoms and 8 hydrogen atoms, which makes 11 atoms total. So I plug this in, 5 times Avogadro's number. And I get 3.31 times 10 to the 25th atoms. C3H8. Now, don't forget about the gram. The gram could be put in here as well. So, change the color up. Say I want to find out how many grams of sodium chloride are in 1.05 times 10 to the 21st molecules of sodium chloride. Okay, so once again, we start with what we know. We know 1.05 times 10 to the 21st. Erase that. NaCl, right? Remember, sodium chloride's NaCl. So now, we're in molecules, we want to go to moles. So we're in times 1 mole. It's not asking for atoms. You don't have to count any atoms. We're just going to go 1 mole of NaCl all over 6.022 times 10 to the 23rd molecules NaCl. Now, our last step, we need to convert to grams of NaCl. And I'll just put this down here. There's not enough room. So we will have 1 mole on the bottom. We want to get rid of the moles of NaCl. And we want to go to grams of NaCl. So now we need the molar mass. So we have 22.99 plus 35.45. And we get 58.44 grams of NaCl. So now I plug in our calculator. 1.05 times 10 to the 21st divided by 6.022 times 10 to the 23rd. Times 58.44, and we get 0.10 grams of NaCl. Okay, now the last part of this video, we're going to talk about percent composition. And percent composition is as follows. We're going to have a mass of an element all over mass of a compound times 100%. And since it's percent composition, our unit will be a percent. Now, to put it in simpler terms, instead of worrying about mass of an element over mass of a compound times 100, we could just say part over whole times 100%. Okay, we'll do 3 examples, and we'll be out of here. So, first one's going to say we're going to have a 13.60 gram sample of a compound, and it contains magnesium and oxygen. And I'm going to tell you that we have 5.40 grams of oxygen present. So the question is, what is the percent composition of this compound? So if a question ever asks you what's the percent composition of this compound, they want to know the percent composition of each element in the compound. Now we need to figure out our compound. So we have magnesium and oxygen. So we know we have MgO. So they tell us the mass of our sample, 13.60 grams. They also tell us our oxygen, so 5.40 grams. So how are we going to figure out our magnesium? We're going to subtract. So we'll subtract 13.6 minus 5.40, and we get 8.2 grams. So 8.2 grams of magnesium, 5.40 grams of oxygen, and we have 13.60 grams of MgO. So now we're going to calculate our percent composition. So we'll calculate the percent composition of oxygen first. So we have 5.40 all over 13.60 times 100%. So 5.40 divided by 13.60 times 100%, and we get 39.71%. And remember, you want your total percentage to equal 100, so make sure we round to the appropriate decimal place. And now our percentage of magnesium, we will have 8.2 grams over 13.60 times 100%. And we will get 60.29%. All right, so now say if I just give you, let's see. So if I gave you ethane, C2H6, and I want to know the percent composition of ethane. So the first thing we need to do is calculate the molar mass of this ethane. So I have 2 carbons and 6 hydrogens. Remember, we're going to substitute our chemical symbol for the atomic mass. So 2 times 12.01, and then 6 times 1.01. So we'll have 24.02 and 6.06. So add those 2 numbers up. I'm going to get around 30.08 grams per mole. So that's our molar mass. So that's our whole. But we also figured out both of our parts here. So our percent composition of carbon would be 24.02 all over 30.08 times 100%. So we'd have 24.02 divided by 30.08 times 100%. And we will get 79.85%. Now, percent of hydrogen. So we'll have 6.06 divided by 30.08 times 100%. And we'll get 20.15%. Now, those 2 examples made us calculate the percent composition of each element. You might have one where you don't have to do that. So say we had NH3, which we know NH3 is ammonia. So I just want to know the percent composition of nitrogen in NH3. So the same steps apply. I need to calculate my molar mass of NH3. So I have 1N and 3H. It will be 1 times 14.01, the atomic mass of nitrogen, and 3 times 1.01, the atomic mass of hydrogen. So we'll have 14.01 and 3.03. So if we add those two numbers together, we'll have 17.04 grams per mole. Now, they do not want to know both the percent composition of both elements. They just want to know nitrogen. So that's all we're going to do. Don't do more work than you have to. So percent of nitrogen. So we have our part, 14.01, all over our whole, which is 17.04 times 100%. And we should get around 82.22% nitrogen. And this concludes our video on mole conversions, part 2, and percent composition.